right now. We'll go back, we'll talk about metals. Metals do two things. They make metallic bonds and they make ionic bonds. But right now we're just sticking nonmetals together. And the reason that happens is because all of these nonmetals are more stable when they have a full octet, right? So that would be 2 valence electrons for hydrogen and 8 for everything else. So the way that they get a full octet is, what do the nonmetals do, Riley Teague, to get a full octet? Riley Teague.
Share electrons.
What was that?
Share valence electrons.
They share valence electrons, making covalent bonds. Very nice. So we're going to start looking at the chemical reactions involving just these. We won't even worry about the other chemical reactions just yet. So what you should have seen there, and I'm going to do what's called a word equation. Word is they took water, and this little line means that there is a chemical equation, and you're going to read this in just a second here. But whenever you have a chemical equation, you are forming new products. So you are forming things that did not exist before. So water has very specific chemical properties. It does what water do. In order to do that, you got to run some electricity. There's a really chubby marker right there. You got to run some electricity through it. Thumbtacks and a 9-volt battery. That's kind of cool. And then you get hydrogen gas and oxygen gas. So this is what we would call a word equation. These things over here, this is a specific type of reaction where you only have one reactant. Probably in the backyard. So this would be a word equation. We don't use these too much. What we start to do is we start to do symbols, and then we start to balance those, and then we're going to do math with those. So in that video, does anyone know, how did we know which one was hydrogen and which one was oxygen? Riley Spidell, how do we know which one was which?
There was more hydrogen.
There was more hydrogen. Do you know exactly how much more?
Double.
Double. Whenever you do this experiment, you're going to have twice as much hydrogen as oxygen. Yes? So the reason you have twice as much hydrogen as oxygen is because of what water is. What water is? Yeah, that sounds weird, but that's exactly what it's talking about. This molecule, and you guys already knew this, you're like, is he just talking about H2O? We know it as H2O, but you got to think back hundreds of years when they didn't know what water was. They knew that if you ran electricity through it, you got hydrogen and oxygen gas, and you got twice as much hydrogen as oxygen. And so they came up with this, and then also little things like that, to tell you what that is made out of. So now we're going to put this, and we know we're going to call this H2, and I'm going to put a little G there, which you'll see about in just a second. And then we're going to call that O2, and that's another G. But now there's something wrong with this equation. You'll also be reading about this today. Anyone know what's wrong with this equation so far? This is what you would call a skeleton equation. It has all of the different compounds in it. It's got their state of matter, liquid, gas, gas. But what does it not have? Anybody want to tell me what's wrong with it?
The right numbers of atoms.
Nice. It doesn't have the correct ratios of those things to make it balanced. Right, so if you look over here, you got 2 hydrogen atoms in our reactants. You got 2 hydrogen atoms in our products. That looks good. But you have 2 oxygen atoms over here and only 1 oxygen atom here. Remember the invisible one? There's an invisible one there. So you guys will start looking at balancing these things, and the way we do that, if you got 2 oxygen, you got 2 oxygens here, you need 2 there. You put a 2 there, but now you need 2 of those, and you have 1 of those, and it's all balanced. This is a very specific type of reaction. Does anyone know what you call something where you got one substance, you break it into 2 parts? That's what happens to you when you die. Your physical being, sorry, your physical being will go through decomposition. It's when we take a full thing and break it into 2 or more pieces. That's a type of reaction. You're going to be looking at types of reactions. You're going to read about all these subscripts and all this stuff. Ideally, a lot of this is review from middle school, but you know, that might have been a while ago. So let's see. Yeah, and then, oh, we're gonna do this. We're gonna take this. Does anybody know what that is? That, my friends, is ethyl alcohol, and we're gonna combine it with oxygen. And then there's gonna be exciting things in the garage. That's what's gonna happen. So what I need y'all to do, hopefully you got where these numbers are coming from. You want to pin my video? That's me talking to myself. These subscripts, especially in your compounds, those are coming from very, very careful observations. We will do one. There's one you can do with ionic bonds, which we'll do with some metals and stuff in a couple weeks here. So you'll see where that comes from. So what you should have seen is the reverse of this, where you take hydrogen gas and oxygen gas. And normally I would do this with some balloons. I've never done it with bubbles like the guy in the video, but I have taken a hydrogen balloon. And I remember, like, this was like my favorite things as a little kid, go to Cal Poly, and they had a chemistry show, and they would always like light a giant hydrogen balloon on fire. And it was amazing. An oxygen balloon sinks, and it's not very exciting. A helium balloon just pops. But if you take a balloon that is 2 parts hydrogen and 1 part oxygen, like that guy had, and you light that balloon on fire, it's terrifying. But it's amazing. So that's going to make a gas. So this was a liquid up here. This is a gas, plus you're releasing a whole bunch of energy. So we will come and talk about why energy is released. So like in a exothermic, this one you had to have an energy input because it's endothermic. That energy was electricity. And this is when you're making just one product. What kind of reaction where you make just one product? Somebody by the name of Audrey, what kind of chemical reaction, just has a single product? Audrey Glazer, what do we call it when you take 2 things and smush them into one thing?
A reaction?
It is a reaction, but there are 5 types of reactions, and we're going to deal with 3. You're going to combine. So combination is a type of reaction. So this one up here clearly says decomposition. Decomposition is when you take a single compound and you break it into its parts. The reverse of that is called a combination reaction, or you might hear it as synthesis. So you should have seen, the book talk gave you a bunch of examples of decomposition reactions and combination or synthesis reactions. And it also gave you some of these. C2H5OH plus, that's a gas, plus O2, that's a gas. When you take something, and if it's mainly hydrocarbons, which is carbons and hydrogens and maybe some oxygens in there, when you take that and you combine it with oxygen and you give it a little spark, just a little bit of energy to kickstart it, you're always going to make 2 products. Hint, this is combustion. What are the 2 products of complete combustion? Every single time, complete combustion. Stella, did you get what are the 2 products of complete combustion? Ms. Levy, did you get that? There's 2 products for complete combustion. They're the same products every single time. So when you see these 2 products and you see oxygen over here, you know you've got combustion. Nothing from Stella. Flint Knockbar, what do we got? What are the 2 products of a combustion reaction? Oh, Mr. Bell. Oh, there you go.
Energy and I don't know the other one.
Always, always, always carbon dioxide gas and water vapor. So if you burn gasoline completely with oxygen, the only thing coming out of your tailpipe should be carbon dioxide and water. You frequently don't burn it completely. You don't have enough oxygen. But if you burn So this one, these are alcohols, this OH group on here makes this an alcohol. So this is carbon, carbon, and oxygen. And that's the OH right there, is this OH here. And then we need 5 more hydrogens. So this would be an alcohol. If this was just an H, that would be, what is that, butane? I think that's butane. It would be like a flammable gas. But we've got, I just happen to use this one because I have it in a bottle over here, and I'm going to show you what we do with it. So this is not balanced. In order to make a balanced chemical equation, you count up all the atoms in your reactants, and you make them equal all the atoms in your products. And this one's pretty straightforward. We got, start with your carbons. You got 2 carbons. You got 1 carbon. You need 2 of those. And then to your H's, I got 2 H's here and 6 H's there. So I need 3 of these. And then you do your oxygens. That is 4 of those, and 3 of those is 7. And I got 1 here, 2 there. If I have 6 here, I then have 7. So you're going to see that the plan is for you to practice, read that section, practice the Khan Academy before Wednesday, and then I'll give you some things to practice with that. But let's see what this actually looks like. So, camera switch. All right, so what I got here is flammable liquid, wrong turn, ethyl alcohol, C2H5OH. It is denatured, meaning this is not like drinking alcohol. It's got methyl alcohol in there, which is poisonous. And anhydrous means there's no water in there. It's pure alcohol, ethyl alcohol. Let's see, what's that say? Danger. Highly flammable liquid and vapor. Keep away from heat, sparks, and open flames. Harmful if swallowed. All right, let's check. Let's do that. All right. So I'm gonna go. What I'm gonna do is I want to get mostly gas in here. Yes.
May I use your phone?
You may use my phone. It's Mrs. Mello using my phone. So ethyl alcohol. I only need a little bit because I want it to turn into gas. And so I try and coat the entire bottle with this. And then let's go over here. Let's see, hover cam. Flip that. Got my tools over there. It's laundry. It's the laundry area, Mr. Mello's house. Okay. So I want to make it darker in here. Ooh. All right, I'm over here. You see me? Let's see. So I've got most of the alcohol. I've got most of the liquid. I'm going to dump it out. So I've just got mainly gas in there. And then we want oxygen in there. So I open it up and it'll be 20% oxygen. It's not going to be super duper exciting because the air in my garage is only 20% oxygen, sorry. It's not 100% oxygen because that would be weird. All right, and is that what I need? Oh, there we go. Okay. Let me see the bottle. Okay, you're gonna want to watch this. If you weren't paying attention, now will be the time you want to pay attention. I'm gonna take a match and I'm gonna drop it in there. I am shaking a little bit because that's what I do when I burn things in my garage. Hey, watching. Ooh, that was a good one. Oh gosh, it's gonna be melting the top of the lid. Ooh. Ah. Ooh. And a thunderous applause, thunderous applause.
That was so cool.
Is that fun? That worked.